What is isometric drawing or isometric view? So these two are actually 3D drawing in which the drawing represents three dimensions: length, width, and height. So first of all, we see different types of 3D drawings. Here, the axonometric projections. It is a type of pictorial projection in which all three dimensions of an object is shown in one view. So first is isometric projections, diametric projections, and trimetric projections. So in this object, the first isometric projections are the projections in which the three mutually perpendicular axes of the object, means length, width, and height, these three lines are equally inclined to each other. Means the line from OX, line OY, and line OZ, the angle between OX and OY is beta, ZO and OY gamma, and OX and OZ alpha. So the angle alpha, beta, and gamma are equal, and the length of OX, OY, and OZ also equal. But in diametric projection, the angle alpha, beta, gamma, in which the angle alpha and beta is equal, but gamma is not equal to alpha and beta. So here OX and OY equal, but OZ is not equal to OX and OY. So this type of projection is known as diametric projections. And in diametric projections, all the angles alpha, beta, and gamma are different, and all lengths OX, OY, and OZ are also different. So we are concentrate on isometric projections in this chapter. Now, types of isometric drawings. So there are two types of isometric drawing. First, isometric view, or it is also called isometric drawing, and isometric projections. Both are 3D drawings. Both are represents length, width, and height. But what is different between these two? Here in isometric view or drawing, it is drawn by using the true scale, means true dimensions. Whatever the dimension in orthographic projections, same dimensions are used for 3D drawing. That type of drawing is known as isometric view or isometric drawing. And when we reduce all the dimensions for 3D drawing, then that type of drawing is known as isometric projections. First, see what is isometric view. How to draw any 3D drawing? We have to draw first horizontal line. From any point, draw 30-degree anti-clockwise and draw one line. Another line which is clockwise 30-degree from O. And third one is always vertical lines. So these three lines are basic lines for any 3D drawing, in which these two lines represents length and width. This is for height. Suppose we are using one rectangle prisms for 3D drawing. So in which this is length, this is width, and this is height. So you take particular dimensions for length L, width W, and height H. So these three dimensions are true dimensions of the object. If in our rectangle prism, suppose length of the object is 50 mm, so here we have to draw exactly 50 mm. If width is 20 mm, then this is exactly 20 mm, and height is 80 mm, so it is 80. Now draw a line from this point parallel to L line. From this point, draw a line parallel to width line and one line parallel to H. Again, line L, W and H. So this is one 3D object which represents 3 dimensions, and the angle alpha, beta and gamma are equal, which is 120 degree. So this is an isometric drawing which represents true dimensions of the real object. But in isometric projections, all the dimensions are reduced. So how many percentage are reduced? For that we have to draw one isometric scale. So how to draw one isometric scale? This isometric scale is used to reduce all the true dimensions into isometric length. So first of all, draw one horizontal line AB. From A, draw a line AC which is 30-degree inclined to AB. That line is known as isometric length. Now from A again you have to draw 45-degree inclined line AD, which is known as true length. If you want to convert the true length into isometric length, then you have to mark on true length 0 to 1, 2, 3, 4, 5, etc. Suppose this is 1 centimeter or 10 mm. So here is from 0 to 1 is true length of 1 centimeter or 10 mm. But when we draw the vertical line from 1 up to isometric length, that point is 1 dash. So here A1 dash length is known as isometric length of 10 mm. Similar, 2 dash, here 0 2 means A2 distance is exactly 20 mm, but A2 dash distance is isometric length of 20 mm, which is always less than true length or 20 mm. Similarly, from 3 to 3 dash, draw vertical line 4 to 4 dash. Now, what is isometric length? Which is reduced from true length. So, if you want to find out any isometric length of any dimensions, then the equation is like this: root 2 by root 3 multiplied by true length. You can derive this equation by using trigonometry, cos 30 degree and cos 45 degree. Similarly, isometric length is 9 by 11 into true length, or isometric length is equal to 0.816 multiplied by true length. So for isometric projection, we have to convert this length into isometric length. So L is known as isometric length, which is 0.816 into red L, which is true length. This is isometric length L, this is true length L, and by multiplying true length into 0.816 we will get the isometric length for isometric projections. So in isometric projection 3D drawing, we have to draw horizontal line point 30 degree, 30 degree and vertical line, basic 3 lines. Then first of all we have to insert the length of the object. Now in isometric projections, this length is not 50 mm, but here it is true length 50 mm. So you have to convert this 50 mm into isometric length and then use that reduced length for 3D drawing here. Similarly for width also and height. So these 3 length, width and height are reduced. Now you complete your 3D drawing. So for same object, if we draw isometric drawing, it is 3D drawing in which all dimensions are true length. But in same object, if you want to draw isometric projections, then all dimensions are reduced, means the object is reduced. Now in isometric view or isometric projections, how to draw the circle? Okay, suppose we have given one circle. This is front view or top view of any object. So how to convert this 2D circle into 3D? So it will become oval shape. So that shape is drawn with the use of for center method. So how to use for center method? Let us see. So this is my one view, front view or top view of the circle. This is 2D orthographic projections. So first of all, you have to take horizontal and vertical axis from center of the circle and draw the square. Okay. Insert ABCD at corner of the square and PQRS midpoint of every side of the square. Here the dimension for the square means the length AB is equal to diameter of the circle. First we have to take isometric view or isometric drawing for top. Suppose this is top view. It looks in 3D. So first of all draw horizontal line and from any point take 30° anti-clockwise, 30° clockwise. Draw a line is equal to AB. This is BC, CD and D. Now this square become a rhombus in isometric drawing. Then you have to join two opposite corner BD and AC. Find center and find the midpoint of every sides by taking parallel line to this from O and parallel line from O which is parallel to AD. Now midpoints P, Q, R and S. Now, after doing this, which diagonal of rhombus is short or which one is the small diameter? So here DB and AC are diagonals in which AC is small. So you have to take two centers A and C. From A draw a line to opposite side midpoint R and opposite side midpoint Q. AQ. Now take C to S and C to P. Now the intersection of CS and PD is M and CP and DB is N. Actually name of the method is for center method. So we have to draw four arcs by taking different four centers. Now take A center, AR radius, draw arc from R to Q. C center, CP radius, draw arc from P to S. M center, MR radius, draw arc from S to R. And NQ radius, draw arc from Q to P. So this is an isometric circle in top view. What is front view? Suppose the circle is front view, then In isometric drawing, you have to draw horizontal line from any point, draw a line. The length of this line is equal to AB, which is the diameter of the circle. Insert ABCD. Because in front view, we can see the length and height. But in top view, we can see length and width. So here AB is length and AD is width. But when we draw front view, then AB is length and AD is height. Okay, now join AC diagonal and BD. Find out midpoint or center. Draw a line from O parallel to AB and line from O parallel to base C. To obtain the midpoint of every sides, PQRS. Now which one is smallest diagonal? So here BD is smallest diagonal. So draw a line from B to R, B to S and D to P, D to Q. M and N intersection of DP AC and DQ is. Now D center DP radius, draw arc from P to Q. B center BS radius, draw arc from S to R. M center MP radius, draw arc from P to S. N center NR radius, draw arc from R to Q or Q to R. So this is a method, four center method for convert the 2D circle into 3D ellipse or oval circle. Thank you very much for watching this video.